Okay, think about that water filter pitcher you have in your fridge. What if you never had to toss out the filter again? Well, a brand new scientific breakthrough could make that a reality. And today we're going to break down exactly how it works. So let's start with a question I know you've probably asked yourself while staring at that wall of replacement filters in the store. Why on earth do we have to keep replacing them every couple of months? It just feels so wasteful, right? And yeah, you are definitely not alone. Over 100 million Americans use these at-home water filters. That is a literal mountain of plastic, and let's be honest, a huge recurring cost, all because these things are designed to be disposable. So what's the deal? Why do they expire? Well, to put it simply, your filter just gets full. It's designed to trap all the gunk from your water, but eventually it hits its limit. It gets saturated, and once it can't hold anymore, it stops working. At that point, it's pretty much done, and off to the landfill it goes. Okay, so to really get why this new tech is so cool, we've got to pop the hood on the filters we use right now. Let's talk about the current champion in the world of water pitchers, activated charcoal. So activated charcoal, it's basically this super porous stuff. Think of it like a kitchen sponge, but with millions and millions of microscopic little pockets and pores. As water flows through, the contaminants literally get stuck in those tiny spaces. But just like a sponge, once all those pores are clogged up, that's it. Game over. It can't grab onto anything else. And that right there is the big problem. The science is super clear on this. To keep working, that saturated filter has to be thrown out and replaced. There's no way for you or me to just clean it out at home, which, of course, sets the stage for something way smarter. And here it is. Let's introduce the hero of this story. A completely new kind of filter cooked up by researchers that's based on a true wonder material called graphene. And this isn't just a small step up, it's a totally different way of doing things. Now, if you haven't heard of graphene, oh man, this stuff is wild. It's a sheet of carbon that is only one single atom thick. It's unbelievably light, it's stronger than steel, and it has these really unique chemical properties that make it almost perfect for catching all the nasty things we don't want in our water. So, what are its superpowers? Well, like charcoal, it has a massive surface area, but it's also got a couple of secret weapons. First, there's this thing called d-pi conjugation, which basically creates this electronic pull that latches onto metals. And second, and this is key, scientists loaded it up with oxygen groups, which act like these tiny, super sticky chemical hooks that are just fantastic at snagging heavy metals. And just look at how big that difference really is. Your standard activated charcoal filter, it's about 2% oxygen. This new graphene oxide filter, we're talking 25 to 30% oxygen. I mean, that is a huge difference. It gives it way more of those chemical hooks to yank contaminants out of the water. Okay, this is where things go from just cool science to an absolute game changer. The most incredible part isn't just that it filters better, it's that you can clean it and reuse it right in your own kitchen. The whole cycle is just so simple, it's brilliant. First, you filter your water, and those chemical hooks grab onto heavy metals. Then, and here's the magic trick, instead of throwing the filter away, you just rinse it with some hot water or maybe a little bit of vinegar. That makes the hooks let go of the metals, and they just wash right down the drain. And boom, the filter is clean and ready to go for another round. So, how well does that little rinse work? Well, it's pretty incredible. The research showed that hot water can remove up to 99.5% of the metals it caught. It's basically a factory reset for your filter. And all you need is your kitchen kettle. Okay, so we know it's reusable, which is awesome, but how good is it at its main job? Filtering. Let's put it head-to-head with activated charcoal and look at the actual data. Well, the results are kinda staggering, actually. In the lab tests, the graphene filter removed anywhere from 3 to 65 times more heavy metals, we're talking dangerous stuff like lead and mercury, than a standard charcoal filter. That's not just a little better. That's in a completely different league. And this chart really shows you that performance gap in action. You can see for these key heavy metals, the graphene filter's removal rate, that first bar, is just way up there. Activated charcoal, that second bar, barely even makes a dent in comparison. But the big question is, can it keep it up? And the answer is a big yes. The study ran it through 3 full cycles. Use it, clean it, use it again. And you can see its effectiveness stays incredibly high each and every time.
This thing is not a one-hit wonder. It is a reliable, reusable powerhouse.
So let's just do a quick side-by-side here. Effectiveness, graphene wins by a mile. Reusability, that's a yes for graphene and a hard no for charcoal. How do you regenerate it? Simple hot water for graphene versus, well, you can't for charcoal. It all comes down to how they work. Graphene uses those active chemical hooks, while charcoal just uses passive physical pores. All right, let's pull back for a second and think about the big picture here. This isn't just some neat experiment in a lab. This has the potential to make a really big impact on our wallets, on our health, and on the planet. So, what does this all mean for you? Well, first, it's way more sustainable, and it could cut down on a ton of plastic waste. Second, it's cheaper in the long run. I mean, imagine buying one filter that lasts 3 times as long, maybe even longer. Third, it's laser-focused on getting rid of some of the worst contaminants, like lead. And maybe the best part? The researchers say this tech could fit right into the filter pitchers we already have on our counters. And look, the researchers who did this work, they're not just dreaming here. They see this as a commercially attractive technology. The whole point is to create a practical, affordable, and greener option that could actually show up in your home someday. And that really leaves us with one last big question. This study showed it worked for 3 cycles, but it's really a proof of concept. It opens the door to a whole new way of thinking. So, are we about to enter a future where your water filter isn't a disposable thing you buy every few months, but a durable tool that could last you for years? That is a very exciting thought. And that's all for this explainer.